Right. You see, we saw the address size. We saw how to write it in a simplified manner. Now we are going to see the type of addresses in IPv6. Number one, the unicast address. What is unicast address? The address that takes packet to one particular host, one particular destination. That's unicast, isn't it? So here we have IPv6 unicast address, two types. One is global unicast address. Global unicast address, which will always start with 2000. I told you. It will always start with 2000. Why it is /3? To write that number 2, you need only the 3-bit. That is why /3. So it's not too important here, but you know that. To write number 2, only 3 bits out of 120. Next is link local address. This address is not going to be used by us, but the devices will use this address to discover each other. You remember I told you there is no ARP in IPv6. ARP is not there because ARP does broadcast. Broadcast is bad. As a replacement, we have ICMP version 6 to discover neighbor. And that ICMP version 6 will use this link local address to discover neighbor. Yeah. So unicast address is an address which is pointing towards a particular destination, in which you have two types: global unicast address. The other one is the link local address. Both are unicast. Global unicast addresses are the one which we use to ping, send traffics like FTP, HTTP. We use this address, 2000 range address. But behind the screen, an address starting with FE80, which is a reserved link local address used for neighbor discovery. And these two are unicast address. Now about this link local address, I want to say one point. This link local address can be manually assigned, but most of the time we don't do it. We allow it to dynamically get generated, dynamically assigned. Link local addresses are assigned dynamically. Global unicast addresses we have to assign. Link local addresses are dynamically assigned. When you make an interface as an IPv6 interface, it automatically gets one link local address. Okay, next. Multicast address. We know about multicast address a little bit. We'll be learning more when we are on CCNP, but I want to give you some inputs on multicast address here. An address which identifies group of device. For example, in a school, 10th grade children is a multicast. When I say 10th grade, 10th standard, it is not one student and it is not all student in the school, but it is group of student in that school. Likewise, in networking, we have multicast address to identify a group. For example, we saw in RIP 224009 address to identify RIP version 2 routers. 224010 is to identify EIGRP running routers. 224005 to identify OSPF running routers. Multicast address. In IPv6, all multicast address will start with FF02. You can also say FF00 because that's the range. FF00 means multicast address. Here is some example. FF02::1, which is a multicast that helps to identify nodes like computers, routers, gateways. This FF02 is same like 224. Now, can anyone tell me what will be the RIP, IPv6 RIP multicast address? No, in IPv6. I just told you FF02 is like 224. So what will be RIP, IPv6 RIP's multicast address? FF02::9. What will be the OSPF, IPv6 OSPF multicast address? 5. Okay. So very simple. You need to just put FF02 instead of 224. So that's multicast address. FF02. All right. Now IPv6 OSPF is called as OSPF version 3. So multicast addresses, all multicast address starts with FF02. OSPF version 3 means what? IPv6 OSPF. The OSPF that you learned is OSPF version 2. OSPF version 2 is IPv4 OSPF. OSPF version 3 means IPv6 OSPF. IPv6 OSPF will use FF02::5 and 6. All right. We understood unicast, we understood multicast. There is also an anycast. Anycast is nothing but one to the closest or one to the shortest path. I gave you one example some day before for anycast. I'll try to repeat. But I don't remember the old example which I gave you on that day, but I'm giving you something equal to that. You are going inside a park. You are walking in the park and you are thirsty. It's a very big park. There is a board shows the entire park, and it also shows where all the drinking water tap is installed. Now you can see 5 different part of the park having the drinking water spot. In 5 different places inside the park, you see drinking water tap in the map. In the map of the park, you can see 5 different tap. Now, which one you will choose the closest? In that map, there is also a marking saying you are here. So you know where you are in the park. When you see the map, you know where you are in the park. Now, you see which tap is close to your location, and you drink the water from there. Now, what if the tap is not functioning? You see the map again and see where the next closest water source. You know, it is the same water tap you are looking for, but you don't drink from the same tap all the time. You just choose whichever is closest. First time I was close to dinosaur in the park, and there was one tap near to the dinosaur cage. I drank water in the dinosaur cage. And then I was moving around 2 kilometers in the park. I was near Anaconda. And next to that, there was one tap. I drank from there. I did not go back to dinosaur spot because I need the closest. And then after 2 hours, I was close to that elephant. And there was an water tap there. I drank water. I did not go back to the dinosaur or the anaconda's spot. Same way. You will have same address in different place for some service. Same address. Depending on your location, you choose one of the device. For example, DNS 8.8.8.8 is the global DNS address. Now, a mirror copy of the DNS server is kept in various continents. Same address 8.8.8.8, but because you are in India, you may be accessing maybe Mumbai 8.8.8.8, not Singapore 8.8.8. The closest, you see, that's what called as anycast address. Anycast addresses are assigned to a set of interfaces. It's one address, but assigned to set of interfaces, typically on different device. Same address, but on different device. Like water is same, coming from the same tank, but in different part of the park. The packet sent to Anycast address is routed to the nearest interface. The one who is thirsty will go and drink from the nearest tap. All right. So I give you an example. DNS. Any address can be any cast address. Broadcast. See, there is no broadcast supported in IPv6. IPv6 does not directly equipped to IPv4 broadcaster. Instead, multicast is used to achieve the small functionalities. Broadcast in IPv6 sent to the packet to all devices in the network, but in IPv6, multicast is used to go to a group of people. It's not broadcast. No broadcast is supported. Simple. If you wish to send the traffic to all nodes, then you need to use ff0 to ::1. If you wish to send to all routers, then it is ff0 to ::2. If you wish to send to all RIP routers, ff0 to ::9. Simple. They said broadcast, but they here inside they say no broadcast. We use only multicast whenever we want to talk to many. All right. So global unicast address or the addresses that points to a single device, always starting with 2000. Link local address also point towards single device. This address always starts with FE80. Multicast addresses always FF00. Actually FF02. FF0 is okay. FF, it starts with FF. You can use any address as an anycast address, but make sure you define it as an anycast address. This : addresses, so far no one have. : means what? All 128 bit is 0. Is there any meaning in all zeros? No meaning. So forget about that. Okay, these are the address types in IPv6. Do you have any question? Address type in IPv6. Unicast, multicast, anycast. Any question on this address types? Okay. After reassign, we will ping. You will see not even a single packet getting lost. In IPv4, when you're pinging for the first time, you will see some packet loss. You will see some packet loss. 1 or 2 packets because of the ARP. ARP will always take some time to learn MAC address of the neighbor router or neighbor device. But in IPv6, neighbor discovery happens before you ping. Before you ping, they already know each other. So not even single packet will be lost. You're going to see that. Enable config the host name router A. This is a router. To enable IPv6 routing, you need to type this command: IPv6 unicast routing. Don't forget to type this. If you don't put this, the router is not a router. For IPv6, this is just a computer. If you want this to be a router for IPv6, you need to put this command. All right, let me go to all other routers and do the same. All right. Now let me start the configuration from router 3. Listen carefully. I'm going to show you The IPv6 interface status, show IPv6 interface brief. Wherever we used to say show IP, we need to put IPv6 now. Wherever you used to type IP, now instead of IP, what you are going to type? IPv6. It's the same command you see, show IP interface brief. Only that version is different. It shows that the interface are administratively down. Let's go bring the interface up. No IP, no shutdown. Now I have said no shutdown, but you don't see you don't see any address. You don't see any address, but when I put a global unicast address, link local address will automatically come. See, IPv6 address, I'm saying 2000 colon 2323 colon 3/64. You see, I have given only one address, which is called global unicast address. But when you go here and see now, you will see two addresses. This is what I assigned. This is what called as link local address. This link local addresses are dynamically assigned. Okay, now let us go assign IP address on the loopback interface. Because it's a loopback, I'm masking it completely. Done. Let's verify. Show IPv6 interface brief. You see, even the loopback address have got a unique link local address. Always link local address will start with FE80. Any question? My question is this. When will the link local address come? Answer this. Only when you assign an IPv6 global address, a link local address will automatically come. Your no shutdown will not bring the link local address. Your no shutdown did not bring. Even this command will not bring. Which command? This command will not bring the link local address. You should put some global, some address of IPv6 on an interface. Only then this will come automatically. Let us go to B router. Interface G0001. No shit. IPv6 address. See, instead of saying IP address, we should say IPv6 address 2000 colon 2323 colon 1/64. Interface G000. IPv6 address 2000 colon 12 colon 2/64. Interface loopback 0. IPv6 address 2222. Done. Now you see, I'm going to ping this 3333, which is the loopback of router C. I'm not able to ping. Why? Because there is no route. Isn't it? Do we have a route? No. It's router C's loopback, so you will not be able. But when I ping 2000 colon 23 colon 2. Not even a single packet will be lost. Oi, something is wrong. What happened? What happened? Show IP interface brief. Show IPv6. Is the interface up? And why it's not pinging? Let me see what I gave here. Oh, I put 3 here. I put 3 here. It is okay. Let me go and ping then 3. You understand it's the address problem. 3. Not even a single packet lost. Though I'm pinging for the first time, that is what IPv6. See? Show IPv6 neighbor discovery. Neighbor. It is already learned before you ping. And it is a link layer, link local address. Now, let's move on to router A. Interface G000. IPv6 address is 2000 colon 12 colon 1 slash 64. Interface loopback 0. IPv6 address. What is that? I missed one colon. All right. Now you will be able to ping the very immediate router. See, not even a single packet lost. All right. Now, if you want to ping the other routers, loopback or the remote networks, you need a routing protocol. What we are going to see is EIGRP. Today we have to see static route first. We see in the previous classes on the stub routers we used to configure default route, isn't it? How to write default route on IPv6 router? This is the command. IPv6 route ::/0. Send it to 2000 :12 :::2. That's it. This is what called as default route. Any network, any subnet mask. Let's check the routing table. Show IPv6 route. You can see the default route. But in IPv4 for default route, we used to see a star. Star, star, star. Here you don't see that star. In IPv6 you don't see star, even though it's a default route. Now let's move on to router C and write default route. IPv6 route 0000. No, don't need to put all those zeros. Just put : it understands /0. Means any network, any subnet mask. Send it to 2000 :23 ::1, which is router B. Done. Now, in the middle router, we have to write precise route, not the default route. So I'm going to say IPv6 route. If you want to go to 3333 64, or you can match even 16-bit. This first 16-bit, if it is 3333, then send the packet to next router, router C, which is 2000 colon 23, 23, colon, colon 3. And then IPv6 route. If you want to go to 1111, colon, colon, slash 16, send the packet to 2000, colon, 12, 12, colon, colon 1. This is router 1's address. Right, we are in router B. That's all. You have written static routes and default routes. Show IPv6 route. You can see the static route to reach 1111 and 3333. All the rest of the networks are connected. You see, we have not pinged earlier, but you will be able to ping the very first packet will ping 3333 colon colon 3. What a surprise. This happens only in IPv6. Any question? All right.